Okay, so this is how I might do it if I was tutoring some of the younger kids. This is for number 24. That's where I would start. And I would, so just imagine I have a bunch of little kids around me, and I would say, today, let's do science. Let's put on our lab coat like a scientist. Good. How about our safety goggles? Can we put on our safety goggles? All right. Okay, let's act like real scientists, and we're going to learn the scientific method. Are we ready? Let's do our hand motions. Purpose, that's the question. Purpose, hypothesis, your idea you can test, hypothesis. Materials, things you're going to use. Procedure, observation, and conclusion, your results, what you learned. Let's do it again. Purpose, hypothesis, materials, procedure, observation, conclusion. Repeat that a couple of times. Good, good. Let's talk about our science experiment for today. Has anybody seen the sun? Oh yeah, it's right there in the sky, right? Is the sun always up? Is the sun always in the sky? No, sometimes it's down, right? Yeah, and what do we call that? Night? Right, we call that night. So sometimes it's up and sometimes it's down. Well, when the sun comes up, it comes up over what we call the horizon. And the horizon, if you look way out in the distance, do you see where it looks like the sky and the earth touch? The sky and the earth meet? That's what we call the horizon. So when the sun comes up, it comes up over the horizon, and when it sets down behind the or under the horizon where we can't see it anymore. So today we are going to learn about why our sun, pretend it's this ball of clay, why our sun, when it dips below the horizon, sometimes we can still see it. And sometimes before it comes up in the morning, before it comes up over the horizon, we can see it. It's a little tricky, right? I'll tell you why we can do that. It's something called refraction. Can you say refraction? Refraction. Good. Refraction is when light bends. That's all. When light bends. And when light bends, it makes us be able to see something in a different place. And that's called a mirage, where our eyes get to see a reflection of something that's in another place. So let's see if we can make a mirage today. Let's see if we can cause light to bend and see what that looks like. Are you ready? Okay, let's talk about our materials. Today we have this bowl and we have these chips and the clay. We're going to put the chip, I'm just going through this part quickly, the chip on the clay on the chip and stick it in the bowl. Okay, good. Now, here's our hypothesis. If we pretend that this chip is the sun, you know what, I actually wouldn't do that. Yeah, I would. Let's pretend that this chip is the sun. And this right here is our Earth's atmosphere. Do we remember the layers of the atmosphere? Who was with me last year? Laquita, you won't have any of this. But who was with me last year? Let's say it. What are some parts of the atmosphere? Some parts of the atmosphere are troposphere, mesosphere, thermosphere. Oh, now I've forgotten it. Where's Jonathan when I need him? Anyway, look it up, Cycle 1. Parts of the atmosphere. You can have them do that if you'd like. No need to spend time on it if you don't. So what do you think will happen when we pour water into this container? Do you think that the coin, our sun, will still be visible when it's barely out of sight? This is actually not a great hypothesis. Sorry about this, girls. Do you think that the sun or the coin will be completely visible when it's part of it's out of sight? Or do you think that it will not be completely visible? Do you think we're going to see a mirage or a reflection of it somewhere else? Let's give it a try. Yep, a hypothesis, not the best for today, but you'll work around it. Pour it in. You have your students stand in the right spot, have the helper pour it in. Go, oh, okay, you can see it. You can see the actual coin is blocked. Our actual sun is blocked some of it. But in the reflection, we can see the whole coin. That's pretty cool, right? We made light bend. That's called refraction. The refraction made a reflection. Can you say refraction, light bending? Refraction, good. Can you say reflection? That is an image projected, kind of like when you look in a mirror, if you wanted to say that. Reflection, good. Okay, so let's make our observation. Let's draw what you see. Draw a bowl, and then take them to the conclusion. Okay, so remember we talked about a reflection of the sun is visible, although Laquita, really, you do not have to take the students through circling this. That is, for them, not the purpose. A picture would be darling. And, you know, you can go through the why if you want for the youngers, but I think that makes it simple and concise. They get to see the mirage, and it still is engaging enough that they can observe, and we're practicing their skills of observation. Obviously, I did that really quickly, but I hope that that helped you. And the next one is distortion. Okay. So I might say, I'm just going to bring a chair. All right, so you remember in the experiment we just did, the water was acting like our atmosphere. I didn't mention that. You can mention that. The water acts like our atmosphere and causes the light to bend. Well, let's see what else we can do. Let's pretend this magnifying glass is our atmosphere. And let's draw a circle in this circle to represent the sun on our paper. Okay. Oh, this one has the layers of the atmosphere on it. Number 26. You can tell I didn't look at this one very far in advance. Layers of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And there's a couple of URLs on there if you want. This is the example of the distortion, and I did not print off the density of the layers, but maybe for the older classes that might be something that's interesting to you. So, how do the layers of the atmosphere affect the viewed shape of the sun? Okay, so we would talk, so remember we saw that when light bends, it can move where it can make the sun look like it's in a different place. Let's see what else our atmosphere can do. Do you think it can make the shape of our sun look differently? Do you think we can make light bend in such a way that it would make it change shapes? Let's look. Okay, let's get our coin, draw the circle. Good. All right, let's get our pretend atmospheres. Got them? Okay, moving around. Does it still look like a circle? Yeah, look, what do you see? Good. Okay, now everyone take it a little bit far away and tilt it this way. Do you see how in the center it looks, when you look at it through the center, it looks a little more distorted at the bottom? That's because the magnifying glass is thicker in the center, and that causes light to bend at a different place than it does on the edges, and that's why your circle looks distorted. Can you observe that? Do you see? Can you observe? Good. Let's draw, you know what? We should just draw the circle right in their book. I don't know why I didn't think of that. We're going to draw the circle right in their book. We don't need this paper. So then they'll do this right in their book. Okay, good. Can you now, right next to the circle that is the round circle, can you draw what it looked like in your magnifying glass?